So let's have a quick look at how this coffee table pinball machine is working at the moment. So we've got an old Bally 8-ball champ playfield. No pinball machines were destroyed in the making of this coffee table. That playfield was on its own without a case or any electronics at all, so we're trying to rescue it. So in the bottom of the coffee table we've got 5-volt power supply, and we've got a 48-volt power supply which we've got dialed down at the moment to 46 volts. The actual coil should be operating off 44 volts in the native machine, so we're keeping an eye on that at the moment. So anyway, those power lines come up here where they connect up to a fuse box, and then they split off, so the 5-volt goes directly off to a 5-volt rail, which serves things like the relays and our main MPU board, which we'll discuss in a minute. And then the 46 volt, the high voltage, will come in here onto a relay which is normally off, so when we power on the machine we don't have the high power on all the time. We only turn it on as and when we need it. So that will then follow through into a power filter board. So what that does is it gives us nice clean 46 volt power, and when we start to use the coils it will drain the power from the capacitors first rather than from the power supply, so it stops the power supply from cutting out when we're using it a lot. So we've got two feeds off for that voltage there. So the high voltage comes up here onto the high voltage relay, which we're using at the top of our cabinet here. So that will go off and drive the chimes through these MOSFETs here. And equally we've got a bleeder circuit there that when we turn off our high voltage, that resistor there and the LED there will just soak away the power that resides in those capacitors after a couple of minutes in order to make it safe. And obviously if we're opening this up and we see the LED on, we know we don't start tampering around with any of the cables because we're likely to get a pretty nasty shock. So we also have the high power. This is the original high power lead that goes up into the playfield, and the playfield, each one of these coils that we see here are all connected onto a single ring, and they're all energized, but none of them are earthed. So only when they are earthed will they power on, and we'll come back to that in a minute. So going back to the 5-volt rail, we follow that out, and that will then power this ESP32 MPU. So this does a number of things. So it will control the switches, it controls the solenoids, it controls the LEDs on the playfield. So you can see we've got these little LEDs that have been stapled all over the playfield. These are WS2812 LEDs that we can control the red, blue and green values on these in order to determine what colour they emit and how bright they come out. And then we also have a display. So this is a little LCD display that we've got at the moment, that 3D printed little case for, and we can connect up to our MPU. So if we start off with the switches, the theory of operation here is we will send out 3.3 volts along these lines one at a time, very quickly, sort of 1,000 times a second, and then we're listening here on these lines here. These are the incoming lines, and if any of these switches closes, so let's have a look. So here we've got a little switch here. So if any of these switches close, see their closing connection there, we should be able to detect that, and the ESP32 will know that we've fired a switch and we can handle it. The other thing that we do here is we've got the coil. So if at any point in time the ESP32 wants to fire a coil, it will send out 3.3 volts into these MOSFET transistors. Each of these are, well, they're not transistors, they're kind of MOSFETs, metal oxide field effect transistors. And if you energize one of the legs, it will allow the earth from the high voltage cables here to flow, which will energize the solenoid. So we've got 2 of those boards there with some MOSFETs in each one of these. We've also got a flipper controller here, so we've got a 5-volt circuit that goes to a left and a right flipper button. So on each one of these flipper buttons, we've got the side, I've got a little button here. It's not a proper pinball button, but remembering we're trying to make a coffee table, so we don't want big buttons everywhere. So this sits underneath the rim, and it's got a ground and a live wire. If we connect those 2 things together, that will send 5 volts into one of these MOSFETs, which will then earth the left or the right flipper coil, and that works quite nicely. On this particular table, I've disconnected the flipper coil for the upper flipper. I was having some problems there and it was costing me too much money replacing the coils and messing around. I've just ignored that for now and moved on with the machine. What you'll also see here is we've got some insulation there. We've got some foil, kind of like acting as a Faraday's cage to stop the high voltage wires inducting current through these low voltage wires and giving us phantom switch triggers. We've also got a little ferrite core at the top of the playfield around the switch cables, again trying to reduce interference from these higher voltage cables that we've got here, which it's had a limited positive impact, but where we've got some problems, I'm also looking for those problems in the code and dealing with it. So the other thing we've got here is, obviously we don't want to be having this plugged in the living room all the time, so we've also got connected to the 5-volt rail, we've got a little USB cable here, which if I plug in to a power bank, which is giving us 5 volts, it will power on, and then we should be able to get at least the LEDs firing on, which is quite attractive, certainly at night. So obviously this is powering on quite nicely. I mean, I can press the start button and start a game. We can see that our relay is now turned on, although we've got no high voltage, so we won't actually be able to do anything. But if we were to start playing with some of these switches, you can see that we're upping the score as we go. And that's about it for how it works.